Amniocentesis is an additional family planning option for individuals seeking prenatal testing for genetic disease. My name is Cathy Lawson, and I'm a genetic counselor. I've had the privilege of walking a family planning journey with many, many individuals, including people like yourselves, at risk to have a child with genetic disease. Thank you for the privilege of being able to help you today. Here you'll see a cartoon of an amniocentesis being performed. This procedure is done at about 16 weeks of pregnancy and beyond. 16 weeks is the beginning of the second trimester. And this procedure allows us to withdraw some of the amniotic fluid that's surrounding the fetus. So here you can see a needle being inserted abdominally through the skin of the abdomen of the mother into the uterus and into the amniotic cavity. In that amniotic cavity is fluid that the fetus is swimming around in. And in that fluid are cells that the fetus shed. Those cells contain all of the genetic material similar to a blood sample. Most women say this procedure is uncomfortable in that it's a pinch in your skin and it's a cramp in the uterus. The cramp doesn't last very long, and then there's generally some unusual pressure, but it takes about a minute to do the procedure. It's done in a regular outpatient setting, not in an operating room and not with any anesthesia. What can the amniocentesis tell you? So once we have the amniotic fluid, now we can send that specimen for various different genetic tests. Those genetic tests can tell you the predicted genetic sex of the fetus. If the fetus is male, it can tell you if the male is affected with the genetic condition within the family. And if the fetus is female, it can tell you whether or not the fetus is a carrier for the genetic condition within the family. The types of testing that can be done on the amniotic fluid are multiple options. One is a standard karyotype. A karyotype is a very basic look at chromosomes within a single cell. So you can see here a picture of a karyotype. Many of you will already know that in the bottom right corner, males, genetic males, have one X and one Y chromosome, and genetic females have two X chromosomes. The rest of the chromosomes, numbered 1 through 22, are the same in males and females. This type of analysis, a karyotype, takes about 10 to 14 days from the time the laboratory receives the amniotic fluid. It does not include analysis for any specific genetic syndrome within a family, but that fluid would remain available to move on to doing additional genetic testing as indicated. A separate test that can tell us the predicted genetic sex of the fetus on the amniotic fluid is a test called fluorescent in situ hybridization, or FISH. This is a test done on the amniotic fluid that basically applies fluorescent dye that attaches to certain chromosomes. So on the right-hand side, you can hopefully see these pictures where you can see these colored dots. So in B here, you can see 3 red dots for chromosome 21, 2 blue dots for chromosome 13, 2 green dots for chromosome 18, and then 1 X and 1 Y. So this FISH result tells us the number of copies of those 5 chromosomes, consistent with a male, an X and a Y, with Down syndrome, 3 copies of chromosome 21. So this FISH analysis can tell us how many copies of chromosomes 21, 18, 13, X, and Y there are, allowing a preliminary result in 24 to 48 hours to tell us the predicted genetic sex of the fetus. It, however, does not test for the specific genetic condition in the family. This does, however, allow for a more rapid reflex testing. In other words, if you had planned to do an amniocentesis, but only test a male fetus for the X-linked condition in the family, then this allows us to know is the fetus male or female within 48 hours, and then you can reflex on to the testing of the specific condition in the setting where the result is male. If you were planning to test the fetus for the X-linked condition, no matter the genetic sex of the fetus, then the FISH analysis is actually not necessary. Additional chromosome analysis is also available. This is called a molecular karyotype. In other words, it looks at much more detail of the chromosomes than a standard karyotype looks at. So the cartoon here with the striped chromosomes is a standard karyotype. The red lines back and forth is the microarray or molecular karyotype, and it looks at about 4,000 or 5,000 pieces of chromosomes instead of 46 structural chromosomes. This piece here on the right that's set aside, sorry, on the left set aside, it reflects a deletion of chromosomal material here at the tip of chromosome 4 that would not otherwise be detected by a standard karyotype. This really is additional testing that would be available and would not impact the outcome for the X-linked condition in the family. This microarray analysis gives you more information about the potential genetic health of the fetus. It cannot detect balanced changes where there might be a piece of one chromosome and a piece of another chromosome rearranged, but present. It only tells us if there are extra or missing pieces of chromosomes. And these results, again, take about 7 to 10 days. More pertinent to why you're finding information is the testing for the X-linked condition in the family. And how long these results take depends on the condition itself and the laboratory doing the analysis. But generally speaking, results of a specific inherited condition on a fetal sample take about 1 to 3 weeks. This testing on a fetal sample also would require a blood sample from the mother be submitted at the same time. There's 2 reasons for this. One is the laboratory doing the testing of the fetal sample will want to confirm that they can detect the variant or mutation in the gene within the family. In other words, we want to be sure that the laboratory that reports out a normal test result in the fetus was actually able to detect the mutation in the family. So they use the mother's sample to confirm that, yes, we can see this change in the gene. And therefore, when the fetus is normal, we know that means that the fetus does not have that change in the gene. Additionally, we do a maternal cell contamination study on the amniotic fluid and the blood from the mother. What this is a comparison looking at normal variations in genetic material between the mother and the fetal sample. We want to make sure that the result that we report out is consistent with the fetus and not the mother. Some important considerations when thinking about prenatal testing during pregnancy. One is, and probably one of the most important ones is, anytime we do a procedure on a pregnancy where we're entering the uterus, there's always a risk. That risk with amniocentesis is for miscarriage, and that occurs about 1 in every 300 times we do the procedure, or about 1/3 of 1%. Generally speaking, the results return within the 2nd trimester, usually by about 20 weeks of pregnancy if you have an amniocentesis at 16 weeks. How might knowing this information impact your pregnancy management at this stage in pregnancy? For the vast majority of genetic conditions, there is no in utero treatment. So we cannot actually do anything to change the outcome for the fetus by doing any treatment during the pregnancy when the fetus is diagnosed with a genetic condition. Therefore, families have the option to continue the pregnancy and raise the baby with the genetic disorder, or the option to place the baby for adoption, which is discussed in a separate module. Or you may have the option of pregnancy termination, depending on availability and regulations in your state and geographic region. Amniocentesis is also able to be performed in the 3rd trimester. Some people may elect a 3rd trimester amniocentesis to be able to be prepared for the delivery of a baby with an X-linked condition. This might be helpful in some select circumstances for delivery planning. And that you can discuss with your maternal fetal medicine specialist or genetic counselor. As always, there are financial considerations to take into account, and no genetic testing is inexpensive. If you plan to do testing once you're pregnant and your insurance coverage covers maternity care for pregnancy, the cost of the amniocentesis procedure is very likely to be a covered benefit. The cost of genetic testing on the amniotic fluid is also likely to be a covered benefit, but may require pre-authorization from your insurance plan. The office performing the amniocentesis is likely able to assist in obtaining the pre-authorization for you. If this testing is not authorized, the cost of the testing are as follows. The standard karyotype, about $1,000. The rapid analysis of the number of copies of certain chromosomes, the FISH test, about $1,200. The more detailed microarray analysis, about $3,000. And the cost for the specific X-linked condition, again in the year 2022, on average, about $500 to $2,000. What are some next steps you can take? Should you wish to gather additional, more detailed information and have a more in-depth discussion about your family planning options, genetic counseling in your region is available. You may also speak to a maternal fetal medicine specialist. To find a genetic counselor, you can follow this link. Best wishes.